So let's really get into what a blockchain is. In this explainer, we're going to move past the simple definitions to truly understand the architecture, the security, and the real-world impact of this technology.
Okay, let's start with the textbook definition. At its heart, a blockchain is a decentralized, tamper-proof database that stores information in a chain of blocks. Now, the most crucial part of that sentence is that it works without a central authority. No bank, no company, no single server in charge. That one difference is the key to everything that follows.
Here's how we're going to break this down. First, we'll look at the core architecture, the block, the chain, and the network. Then, we'll see how that structure creates such powerful security. After that, we'll dive into how new blocks are actually created, check out some real-world applications, and finally, wrap up with a balanced look at the potential and the challenges.
All right, first up, the architecture. A blockchain structure is really built on three core ideas that fit together perfectly. The block, which is the container for the data, the chain, which links all the blocks together, and the network, which is the community of computers that keeps the whole thing running. Let's look at each one. It all breaks down into these three essential parts. You have the block, you have the chain, and you have the network. Each one builds on the last to create the whole system. So let's start with the block. You can think of it as a digital box or a ledger page. Inside, it's holding a bunch of transactions. It has a timestamp saying exactly when it was created. And this is the most important part. It contains the cryptographic hash of the block that came right before it. Think of that hash as a unique digital fingerprint. And that digital fingerprint is what creates the chain. Every new block points back to the previous one, creating this secure, unbroken link. It means if you try to change anything in an old block, its fingerprint changes, and the chain instantly breaks. The whole network would know something's wrong. So where does this chain actually live? Well, that's the third piece, the network. It doesn't exist on one central server. Instead, the entire blockchain is copied and shared across a huge network of computers called nodes. Every node has a copy, and they all work together to make sure it's valid. No single person or company owns it. And this unique architecture is exactly what gives blockchain its incredible security. It's how the system creates trust without needing a trusted middleman. The security really stands on three pillars. First, there's the cryptography, those hashes we just talked about. Then there's decentralization, the fact that it's spread out over that huge network. And finally, immutability, the idea that once data is on the chain, it can't be changed. And these three things work together beautifully. Cryptography locks down each individual block, but decentralization is the real game changer. By spreading the ledger everywhere, it gets rid of any single point of failure. You can't just hack one server. You'd have to control most of the network's power all at once, which is practically impossible. Okay, so the chain is secure, but with no one in charge, how do new blocks get added? How does everyone agree on what's true? That brings us to consensus mechanisms. The two big ones you'll hear about are proof of work and proof of stake. Proof of work, which is what Bitcoin uses, involves computers competing to solve incredibly difficult math problems. It's super secure, but wow, does it use a lot of energy. On the other hand, you have proof of stake. Here, people lock up their own coins as collateral, or a stake, for the chance to be chosen to validate transactions. It's way more energy efficient, but comes with its own debates about security. And while there are other ideas out there, these two are really the foundational models that power almost every major blockchain today. So that's the tech behind it all. But where is this stuff actually being used in the real world? Let's talk about the practical applications. Of course, it all started with cryptocurrencies, Bitcoin, Ethereum, but it has grown so much since then. Now we have smart contracts, which are basically self-executing agreements that live on the blockchain. We're seeing it used for financial transactions without banks, for tracking products all the way through a supply chain, for creating secure digital identities, and yes, for NFTs. This quote really hits the nail on the head. We're not just talking about digital money anymore. The range of potential applications for this technology is just massive. But it's not all smooth sailing. To really understand blockchain, we have to be honest about both the incredible potential and the very real challenges that come with it. And this table lays out the trade-offs pretty well. The advantages are huge. It's transparent, it's tamper-proof, and there's no single entity you have to depend on. But the disadvantages are just as real. Proof of work's energy use is a major concern, the networks can be slow, and honestly, building and implementing this technology correctly is incredibly complex. Ultimately, what we're looking at is a technology that completely redefines how we create trust in a digital world. But it achieves this with a framework that is, for all its power, fundamentally complex. It presents a powerful vision for the future, but one that is as challenging as it is revolutionary.